Take a minute to imagine this. You're laying in your bed. Your sibling comes into your room, looks at you, and leaves without closing the door. Well, don't worry. T11 has your back with the self-closing smart door. You can close your door without even getting out of bed. Sounds pretty nice, right?
In this presentation, you will explain why we chose to make a self-closing smart door, and we will go through some of our initial ideas and the requirements we chose. We will also have a thorough description of our chosen design, including WDMs, CAD models, and the final construction. We also have included demonstration videos and will explain the future implications of this project.
Before we continue, we would like to introduce our team. So hi everyone, my name is Ved.
Hi, I'm Casey.
Hi everybody, my name is Max.
Hi, I'm Rose.
Hi, I'm Sean.
And hi, I'm Aaron.
Just a note for the audience, since there are 6 people presenting, we will have a photo of the person presenting in the bottom right hand corner of your screen. Currently, there are many problems regarding the way we use doors. There are 3 main areas of concern that our device can address. Firstly, this would act as a way to make homes more secure. This would allow users to remotely check if their doors are closed, and also remotely close and open the doors as well. Next, the elderly can also use this device so that they can open doors without getting up. This can prevent any unnecessary stress on that user group. Lastly, this device can be used for lazy people in general. A growing number of people are becoming lazy around the house. Having this device would help individuals enjoy their preferred lifestyle. In all, these 3 problems, while different, have a common solution that is very addressable.
One of the first things we needed to know for this project is how much force, or torque, it takes to actually open and close a door. For this, we used a digital luggage scale like the one pictured to measure the weight and therefore the force needed to close the latch of a door. We tested various doors of different weights and dimensions to ensure our design would be able to close all household doors. The highest torque necessary was found to be just under 6 Newton meters, so this became our first design constraint.
We began sketching potential designs which fell into one of 2 categories, a small hinge or a device with a body and arm that pushed or pulled the door open from the top or the side. Before creating our WDM, we made a list of critical requirements that included the ability to wirelessly connect to a mobile device at a minimum torque of 5.95 Newton meters, and a total cost of under $200 to produce. From here, we filtered out ideas that we thought couldn't meet the requirements. Next, we decided on our WDM criteria that included torque, ease of installation, frequency of maintenance, aesthetics, compatibility with different types of doors, and total cost. We filtered our designs into 3 categories: hinge, top hinge, which included an arm, or a pusher. The top hinge scored the highest and stood out in the torque category. After selecting our design, the next step was to purchase the essential parts for our model. Following research, we purchased a door closer body and arm, Arduino MKR1000, and a 25 kilogram servo motor. At home, we had a portable 5-volt, 1000 milliamp hour battery pack that we decided to use.
So to attach the servo to the door, we decided to come up with a design. Each member created their own design and we discussed each one. Various designs are quite similar, so we ended up deciding to group them and discuss them as groups. We ended up going with a L-style bracket, because it was simple and easy to manufacture and also readily available on the market. The one we went with was similar to the one shown in the middle picture here. However, with the manufacturing style, we decided to create a WDM to decide on what kind of manufacturing we would go with. So here's our WDM. As you can see, we either had a metal bracket or a 3D printed one. And we had our evaluation criteria, ease of creation, installation, compatibility, and cost. And we had our weights, how we thought, and the scores. And we discussed each one pretty in depth. We have full justifications and those will be in our report. However, they couldn't really fit here on the screen. And as you can see, the 3D printed one ended up winning. So here is our Solidworks for a attachment mechanism. It's just a simple L bracket. and two of them attach to the door, and the servo sits on top of it. And it can be seen in the demo video at the end. And here's a model for this servo to arm bracket. So as you can see on the underside here, we have a cutout for the servo horn. And obviously this is where the servo horn sits. And on the top portion, we have a cutout that fits the end of the door arm. And the door arm slides right in here, and it holds it in place to allow movement along with the servo.
These pictures show the components and assembly process for the device. The battery and electronics are friction fit between the L brackets. The electrical aspect of the project ended up being quite simple. The Arduino is powered by the 5-volt, 10,000 milliamp hour power bank, which is connected by USB. The servo is powered through the Arduino and is controlled with an analog pin. The device uses the Arduino IoT Cloud app for smartphone and desktop. In the app, there are two buttons to close and open the door. There is an indicator that shows the door's current position in degrees. A slider controls the precise angle you want the door to open to. In this video, the device is being controlled by my phone, opening to the angle that I selected. Here, I am adjusting the angle to be much smaller.
The technology we put into this device was specifically designed and chosen to be compatible with the Amazon Alexa smart system. Alexa allows the user to control the device with the sound of their voice, and by downloading the Alexa app, the user can swiftly program the opening and closing functions of the door into it. Then with the simple phrases of Alexa, open the door, or Alexa, close the door can be controlled at the complete will of the user.
Alexa, open the door.
Okay.
Alexa, close the door.
Okay.
Unfortunately, due to UBC's draconian housing policies, we were unable to attach our device to an actual door. So instead we created our own door using a state-of-the-art flat panel cabinet. The cabinet was attached with hinges to a rigid board which essentially served as the wall to which an actual door would be attached to. With its unabridged 180-degree rotational ability, our testing model was able to depict, with 100% efficacy, the mechanics of a real door. Then we just attached the device to the rigid board and cabinet, and operated the door with the device by setting it to open or close.
We have some incredible ideas for this project in the future. The first thing we want to do is make it more aesthetically pleasing so consumers would be more comfortable installing this in their household. Next, we want to make sure that the system is waterproof so that it can be used in outdoor applications. We also want to pair it with a smart lock system so that it can be used together with the lock to fully close and lock the door.
And that brings us to the end of our presentation. We hope you liked it, and thank you for listening.